proficiency tests after receiving poor scores. His weak areas included adherence to regulations, checklist usage, and knowledge of aircraft systems. The revelation adds weight to the theory that pilot error played a key role in the disaster. But there are still two major pieces of evidence missing: Flight 90's engines. Without examining them, the team can't prove beyond doubt that the anti-ice system was off, or that the crash wasn't caused by an engine failure. Then, salvage squads lift the battered engines from the river. 13 days after the disaster, they're rushed to manufacturers Pratt and Whitney for examination. Technicians strip the engines down and painstakingly search for any sign of a mechanical problem. But they find nothing. Then they inspect the anti-ice system. One by one, they check the tubes which carry hot air to key areas of the engine. The results are decisive. The valves inside are closed. The anti-ice system hadn't been switched on. But would this be enough to bring down Flight 90? To find out, the team carries out tests in Boeing's state-of-the-art 737 flight simulator. To their surprise, reduced thrust of 1.7 EPR is just enough to keep the aircraft flying. But then, when they factor in the problems created by ice or snow contamination, they make the breakthrough they've worked so hard to reach. January 13th, 1982. A series of factors combine to encourage snow and ice to build up on Flight 90. The aircraft is sprayed with half the recommended amount of de-icing agent. Further delays allow more snow to gather on the 737. And the use of reverse thrust may have sprayed slush onto the wings and critical thrust sensors. 23 minutes to disaster.
Electrical.
Wheaton and Pettit leave their engine anti-ice system off. As a result, thrust sensors in both engines freeze up, causing them to send misleadingly high readings to the cockpit. 14 minutes to disaster. The pilots notice a thick layer of snow on both wings.
And this one's got about a quarter to half an inch of snow on it all the way down.
But contrary to regulations, they don't turn back for more de-icing. 1 minute and 3 seconds to disaster. Pettit is confused by unusual readings on the flight deck.
Look at that. That doesn't look right, does it?
But his captain does not abort takeoff. 24 seconds to disaster. Flight 90 takes off with dials indicating thrust of 2.04 EPR. But because critical thrust sensors are frozen, the real thrust is only 1.7 EPR. At the same time, ice and snow clinging to the wings disrupt airflow dramatically, reducing lift. This changes the aerodynamics of the 737, causing the nose to pitch up sharply. The resulting